Alright, I was just going to show you guys some of the crap I'm working on. So, of course, I'm into redoing these drill battery packs. And that's what's in them is just vape batteries, 5 vape batteries, and a control circuit that goes on there for the batteries and stuff. But this control circuit's burned out on this one, or bad on this one. And so I gotta fix that. But I was gonna be making my own. I've got a whole bag of these lithium batteries, and I'm gonna just make my own control circuit, put them in the box for guys. So that's something I'm working on. But to do that, I've been learning this chip here, and this is my test rig. And this test rig is, 120 volts AC comes in here. Obviously I blew the fuse last time, but it's to test my power supply circuits. And I wind my own coils, and this is for testing the coil to make sure everything's going to work out right with this. So then it'd be just this tiny thing, a capacitor, and a MOSFET, and this to make that 120 volts to anything I want. So that's going to be for the charging unit to charge up the battery packs, and all this circuitry just controls the charging and the balancing between the batteries, because balancing is real important. So I've got to do that, and I'm working on that today some. Well, probably not today. Today I'm working on this. It's a monster, real big microcontroller. It's going to control a bunch of RAM chips and a bunch of analog to digital converters that are super high speed. So it's going to, I'm making my what do you call it? I can never think of the name of it. It's a material science testing unit to yeah, that's too much to talk about anyways, but I got to design that on the circuit board designer so I can cut it out and make my circuit board for it, because it's going to take a bunch of little chips and stuff. This is my wideband oxygen controller chip, but I was going to do this. This controls a wideband oxygen sensor, and then I had my own microcontroller like snooping on the on the oxygen sensor chip and just measuring everything it does. But so I back engineered this chip. I don't need it at all, so I got to take this off and just have this run 2 wideband oxygen sensors with some programming I wrote. So I got to change that eventually. So that's the electronic shit I'm doing right now. And then over here I'm doing the blade. This is going to be for my blade sharpener. This is the thing I cut out. I cut the center cut out. Then I got this far deep into it, and then I started hitting the bolts that were holding it down, so I had to stop it and cut this much all the way around out by hand. So I've got to once I get this, what this goes on to, finished, then I can use that to use the machine to cut that last little bit. So the blade's gonna bolt onto this. This is gonna goes onto this, and this will be driven by pulley to this motor, which I got to make a bracket for. And then this is going to be all automated, and this is going to come in and hit the blade, sharpen the blade down underneath it, hit it again, and then that's going to put the edge on the blade. I got a bunch of new bits to try on this thing. So that's a 12,000 RPM spindle motor, and that's all going to be done by stepper motors, and regular, kind of like 3D printer works, and then the lip gets folded over after it's sharpened. But right now I'm making the bracketry for this. This is making a bracket to bolt onto this part, which is, if you look at my junk pile here, that's what I was working on here. This goes onto here. And then my drill crapped out, so I didn't get to finish that, but that's going to go onto there. And this is going to be the bracket that comes off that everything else mounts to, which will be, I'll have to make another mount for this. So yeah, and then I got that's where I did all the CNC work. I don't know if y'all have seen everything in this room. I haven't took enough video of it. So there's my CNC machine, all homemade from scratch, and that's where I cut the round out on. So this is a lot of work to build probably a $20,000–$30,000 CNC machine for all from scratch. And I'm running out of room, so I've got a big mess here. You know, I got just piles of. See, I got all the wood. I got some nice wood, and once I make this spectroscopy machine, spectroscopy, whatever it is, you hit a pulse into the material, and you measure what frequency the pulse comes back at. So you're basically finding the resonant frequency of the molecules in a substance. That's spectroscopy. That's what that's going to be for, and I'm going to make a nice box for it because I got some other things that need to go in it. Like this is a variac, an AC variac. I've had it in this plastic tub for years, and it's all broken. So I'm going to put that in the box and make that real nice, and basically make a whole voltage supply spectroscopy, spectral analysis, or whatever, So those are the things I'm working on. Oh, and then I got this damn welder, my Tig Welder. I found this new piece. This is going to be perfect for the cooling for the MOSFETs. That's all I got. Oh, that's so close to being done. I just haven't had time. And then here's my 3D printer. It's been sitting not working. And I got these are new linear rails for it. High dollar linear rails. Because I changed how the linear rails worked just to try something, and it did not work out. So now I bought these linear rails, and I've never even got to put them on yet. Haven't had time to get that old guy back up and going. So yeah, I'm gonna get back into get some work done. First, battery chargers for all the guys I was doing them for, and spectroscopy machine, and fixing up the wideband oxygen sensor. Those are top of my list right now. So right now I'm going to be working on designing circuit boards, so let me get to it later.